Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is expected value. The concept of expected value of a random variable is one of the most important concepts in probability theory. Let us start with the definition of the expected value. I'm going to just give you the informal definition of expected value. The expected value of a random variable x is weighted average of the values that x can take on, where each possible value is weighted by its respective probability. So here is the formula for the expected value, and it is denoted by E of x, and it is often called as expectation of x or mean of x. Mean means the summation. Okay. Now let's move on to the concept expected value of a discrete random variable. Let us discuss one by one. When x is a discrete random variable having a support Rx and the probability mass function p of x with the suffix x, the formula for computing its expected value is a straightforward implementation of the informal definition that I gave you just before. The expected value of Ex is the weighted average of the values that x can take on the elements of Rx. The each possible value x belongs to the Rx, which is nothing but the weighted by its respective probability p of x. Okay, let me give you the definition. Let x be a discrete random variable with a support Rx and the probability mass function px of x. The expected value of x can be written as this. You can note down the formula here. Okay, and it should be provided that for discrete random variable this thing is less than infinity. Hope you are clear with this concept. This symbol is indicating the summation over all the elements of the support Rx. Let me show you one example. Let Rx be 1, 2, 3. These are the elements, and then this formula, the expected value would be. So this is how we find the expected value of a discrete random variable. But there is a requirement. Requirement is nothing but the left side, the right side of the formula with a modulus sign should be less than infinity. That is called the absolutely summability. And you should ensure that the summation is well defined. Also, when the support Rx contains infinitely many elements. Okay. So when you're summing infinitely many elements, many terms, the order in which you sum them can change the result of the sum. However, if the terms are absolutely summable, then the order in which you sum becomes irrelevant. So this definition of the expected value, the order of the sum is not specified. Therefore, the requirement of absolute summability is introduced in order to ensure that the expected value is well defined. When the absolute summability condition is not satisfied, this one. If this condition is not satisfied, we say that the expected value of x is also not well defined, or you can say that it does not exist at all. Hope you're clear with this concept. Okay, let me take a probability mass function and then explain you. Here is the example. Let x be a random variable with support Rx. It has the element 0, 1, and the probability mass function is 1 over 2 if x is equal to 1 and 1 over 2 if x is equal to 0. Otherwise, the probability mass function will be 0. So let's find the expected value. The expected value is, I'm just going to apply the formula. Here is the formula. So I'm just going to plug it. When x is equal to 0 and 1, because you just have two elements, 1 and 0. 0 times p of x when it is 0. When x is equal to 0, p of x is 1 over 2. And when x is equal to 1, p of x is 1 over 2. So 0 times anything is 0. So this term will vanish, and half times 1 is half. Hope you're clear with this example. Hope you got an idea on the expected value of a discrete random variable. Now let us see what is expected value of a continuous random variable. When x is a continuous random variable with probability density function. Previously we taught probability mass function. Here we are going to see probability dense function f of x of x. The formula for computing its expected value involves an integral. So which can be thought as the limiting case of the summation. Summation of x belongs to Rx, the mass function found in the discrete case. So let's see the definition. Let x be a continuous random variable with probability density function f of x of x. The expected value of x is, again it is denoted by e of x only. The formula for this one is integral over negative infinity to positive infinity x times the probability density function f of x dx. Provided that, even in the previous case we provided that the right thing is less than infinity. Here I'm going to take there we use the term absolute summability. This is called as absolute integrability. So this requirement should be satisfied. Roughly speaking, this integral is the limiting case of the formula for the expected value of the discrete random variable. Here px of x is replaced by fx of x, the infinitesimal probability of x, and the integral sign is replaced by the summation sign. The requirement here is integral over negative infinity to positive infinity x, the modulus of x, f of x dx is less than infinity. Please remember this. This is called the absolute integrability, and this ensures that the improper integral over negative infinity to infinity x times f of x dx is well defined. Hope you are clear with this concept. This improper integral is a shorthand for, so this is the shorthand for the improper integral, and it is well defined only if both the limits are finite. Absolute integrability guarantees that the latter condition is met and the expected value is well defined. And what will happen if the absolute integrability condition is not satisfied? We say that the expected value of x is also not well defined, or you can say that it does not exist at all. So again I'm going to take one example and explain you this concept. Here is the example. Let x be a continuous random variable with support Rx belongs to 0, infinity. And here is the probability density function f of x of x. So this is how it is defined. So let's find it. Where lambda is greater than 0. So its expected value would be, I'm just going to write the formula and plug in these values. Here is the formula. Now let's plug in the values. It belongs to 0, infinity. So you should start from 0. And the function is lambda. Okay, I'm just going to plug in these values. Now here I'm going to change the variables. Let lambda x be t. For convenience I'm just changing. And I'm going to integrate by parts. So in continuous case you will be using integration by parts and all. I have changed the variable t equal to lambda x. Now integration by parts. Find the integration for the first term and keep the second term as it is. Okay, finding the integration for second term, and then so if you integrate t you'll be getting 1, or I'm just going to apply the formula straightly. So again this would be, so you'll be getting 0 plus 1 here. So 1 over lambda times 1 is 1 over lambda. That's it for this example. So whenever you get integration, get ready for doing integration by parts. Okay, we have seen two cases in the expected value. Now we are going to see the third, expected value of random vectors. Let x be a k-dimensional random vector and denote its components by x1, x2 to xn or xk. Its expected value is denoted by e of x. This is nothing but a vector of the expected value of k components of x. For example, x is a row vector. I have given you the row vector. So hope you hope you are familiar with the matrices form. You can also see the expected value of random matrices. Let summation be k by L random matrix. That is a k by L matrix whose entries are random variables, and denote its ijth entry by summation of ij. The expected value of the summation is denoted by E of summation. This is just a matrix of the expected values of the entry summation. So these are the basics of the expected value. These formulas will be the formats, and the formulas will be helpful in the problem solving. You will also see interpretation of expected values, properties, formulas. So we can discuss those one by one with suitable examples in our upcoming video. In case if you get any query regarding the basics of the expected value, kindly let me know.